Today's topic is AOP. I sent the poll to the attendees to see whether anybody has attended Spring AOP. So a lot of topics that today's the AOP is actually covered in Spring AOP. So I actually intended to make this one relatively short. Okay. All right, so let's move on. But you should be able to get the basic concept of AOP, aspect-oriented programming. So we'll talk about what is and why AOP, and we'll go through some AOP terminology, and then we are going to spend some time on AspectJ, which is a primary, actually the most popular Java aspect framework. And again, Spring AOP is covered in Spring course. So what is and why AOP? So object-oriented programming design is good, and it does let us to make reusable and compact code. However, there is some area that OOP does not deal with well, and that is the code that usually gets scattered in a number of places. So example people use the most to explain this particular, what is called the cross-cutting concern, is logging. If you try to log your application, you find yourself adding or actually implanting your logging code in pretty much every method in your application, and of course that's not really maintainable, and it's hard to actually write that kind of code in the first place. So the issues that do not get solved by OOP are two things. The first thing is what I just mentioned, code scattering. So the concern spread across modules. So we are going to learn the concept of cross-cutting concern later on. But when we say concern, we are talking about some functionality. In this case, in this example, we are talking about logging concern. So logging, if you want to do logging your application, you find yourself your logging code scattered in many places of your application, and that's not really desirable. For example, if you want to change your logging scheme, then you have to go all these places and change, and that's not really desirable in terms of maintenance perspective. Another problem is code tangling. So you have multiple concerns, multiple functionality that you want to implement in your application. Logging is one thing, security is another, transaction is another concern. So if you're not using aspect-oriented programming, instead, if you're just using OOP, you find these concerns are tangled. So you find you're adding, let's say, logging code as well as transaction code and security code in every method of your application. Again, that's not really desirable. So we need to solve this code scattering and code tangling problems. All right, moving forward. So AOP, aspect-oriented programming, is the solution. It addresses these two problems that we talked about, code scattering and code tangling. So instead of adding the logging code in each of the methods, you delegate this logging functionality. Again, this is called the concern. This logging functionality that usually across multiple methods to an AOP container. So you're basically asking AOP container, this is the functionality, a concern that I need to address. Okay, and in fact, you are basically specifying your logging concern in logically a single location, and this single location will be picked up by AOP container, and it is AOP container's responsibility to impose this functionality. Okay, so the container will call logging aspect of the code when the methods are invoked on a proxy object returned by the container. What it means is that, for example, in the case of Spring AOP, in the case of AspectJ as well, what you can say is that whenever a method name which start with XYZ gets called, I want to actually do some logging. So you can specify that kind of what is called the device in a logically a single location, and you're going to see that example in the rest of the presentation. Okay, so AOP and OOP are in fact complementary, so it's not like a mutually exclusive. You want to use both. Okay? So aspects enable modularization of these concerns such as login, transaction, and security across multiple types and objects. So just a little bit of summary. So AOP complements OOP programming. So it basically provides a clean and modular code without additional code plumbing, which means you don't have to change code, existing code, to take advantage of AOP. Aspects can be added or removed as needed without changing code. This is what I just talked about. And the business logic is not tied to any specific API or framework. So you can actually kind of impose, you can add AOP on the top of whatever existing code. So your existing code does not have to be tied up with a particular the APIs or framework. Okay, question from Naidu. Java AOP is part of Java EE6? The answer is yes or no. You know, the AOP functionality, in fact, the Java EE has what is called CDI, and CDI has what is called the interceptor functionality, which is actually providing AOP-like functionality. So in a sense, Java EE is providing AOP-like functionality through different name. Okay. Okay, so going through some terminologies. So we talk about the concept of cross-cutting concerns. So it's a functionality, cross-cutting concern is a functionality that cut across multiple objects and methods. So examples of cross-cutting concerns include, we talk about logging, transaction, security, auditing, locking, event handling, caching, and things like that. Okay. Aspects. So it's a modularization of a concern that cuts across multiple objects and methods. So I said, you know, a few minutes ago, the ideal situation is that you want to actually specify your, you know, the logging advice in a logically single location, right? And you specify that in the form of what is called the aspect. And you're going to see example of that in a few minutes. So if you don't understand what I meant on this slide, don't worry about it. So once you actually see example code, then, you know, it will come to you. So what is an advice? So this is the code that gets executed at a particular join point. Okay? So the type of advice is going to be before advice, after advice, and around advice. So what it means is that before advice is like if you want to perform logging before a particular method gets invoked, in that case you are going to use a before advice. If you want to execute the logging after your target method has been executed, then you are going to use after advice. Around advice is before and after. If you want to do something before a method gets executed, and if you want to do something after that method is finished, then you are going to use around advice. Now, these advices are going to be executed, you know, before and after and around join point, and we're going to actually see what join point is. Join point is a point in the execution of a program. So examples of join points are like a method invocation. So as I said before, you know, if your join point is like a method execution of whenever a method name XYZ gets started, you know, I want to actually perform logging. Okay, so I want to perform logging before or after, or do something before and after. So depending on what type of advice you want to use. Another example of join point is exception handling. So as you will see later on, well, actually, let's move on to the next slide. So point cuts is an expression for selecting one or more join point. Okay, so this is basically expression you're going to see later on. So this is like, you know, you can specify point cut definition, indicating any method name XYZ gets executed. You know, I want to actually perform some the logging. Okay, so by creating point cuts, you gain fine-grained control over how you apply advice to the components. So typical join point is a method invocation, as we said in the previous slide, and typical point cut is a collection of all method invocation in a particular class. So again, you know, if you don't understand what I'm talking about in on this slide, don't worry about it. Once you actually see the example code in a few minutes, you'll actually get the point. But I want to actually describe these concepts first. Okay. Point cuts can be composed in complex relationship to further constrain when advice is executed. So in fact, you can actually define multiple point cuts. You can do some OR operation. You can do some inheritance between point cuts and things like that. All right, so target is the target object. Okay, so it's an object where whose execution flow is modified by some AOP process, and sometimes it's called the advice object because advice is going to be planted before and after or around the target. Okay, concept of weaving. So it's a process of actually inserting aspects into the application code at an appropriate point. So there are two different types of weaving. One is compile time weaving and the other one is runtime weaving. So compile time weaving is that you actually in fact changing the bytecode. Runtime weaving is that your advice will be inserted before the code during runtime. Okay, introduction. So again, these are the things that we actually talked about in detail, Spring AOP, with some examples. So it's a process by which you can modify the structure of an object by introducing additional methods or fields to it. So example of introduction is that, in Java, you cannot have, let's say, the multiple parents, right? You cannot actually add a new implementation to an interface, right? By using introduction, by using AOP introduction, you can in fact actually add a new implementation to a new interface to a class, and you can in fact have a multiple parents, so to speak. So it does actually support multiple inheritance kind of functionality. Okay. All right, so let's move on. Types of AOP. So static AOP and dynamic AOP. So this is the compile time weaving, and this is a runtime weaving basically. Okay, AOP tools. So AspectJ is the most popular, the Java AOP tools, and the Spring AOP is a subset of AspectJ. They actually take the subset of AspectJ and then use it for various functionality in Spring Framework. For example, like a transaction security, all those things are in fact implemented through the AspectJ based AOP functionality. All right, so let's move on to AspectJ. I'm actually waiting for the code to show up. All right, good. So now we are going to actually build our simple Hello World AOP application, and these are the steps that you're going to follow. And now, once you see the code, then you're going to see, you're going to actually have a reasonably good understanding on those concepts that we talked about. So we want to write the target class, and then we are going to write the aspect. So here we are going to define the join point, and we are going to write an advice, and then we are going to write some wrapper or testing code, and then we are going to compile those code. We are going to actually compile both aspect and Java code. Aspect is in the form of Java file, okay, and then we are going to run the application. All right, so let's move on. Step one, this is the target class. So this is nothing different from what you expect from a typical Java class. Okay, so we have Hello World class. It has two methods. One is called the say, and it receives a message and it just displays the message. And then we have another method called the say to person, and it receives the message as well as the name of the person, and then it's going to display the name of the person, comma, and the message. Very simple Java class. All right, so this is the most important slide in this presentation. Okay, so for those of you who didn't get the concept, you will get the concept in this slide. So this is definition of an aspect. Okay, so you're going to say public aspect, and this is the name of the aspect. But by the way, this is the Java file. So it's manners aspect, the Java file. It's not in fact the Java, let's say the Java syntax. Okay, so you're going to use different compiler called the AJC, which understands this particular the aspect syntax as well as Java syntax. Okay, but the actual name of the file is going to be the Java. So by the way, one thing that I have to actually remind you that you can actually use the annotation as well. So you can say at aspect, and then in that case you don't have to actually use this aspect. Okay, so actually, in fact, I have to change the slide and Hansel to use annotation because that's actually a more popular form of defining AspectJ the aspect right now. But the concept is pretty much the same. So this is aspect. I'm defining what is called manners aspect. Okay, now we are defining point cut as well as advices. Okay, so here point cut. So this is the keyword of AspectJ, and this is the name of the point card. So what I'm saying is that whenever any method who has whose actually signature is like public static and returns void, and on the package of hello world and dot say, then star and whatever number of arguments. So what I'm saying is that whenever a method which start with a say on the hello world package and it returns void and they are type of public and static, whenever that method gets executed, I want to perform these advices. In this case, before advice and after advice. So in this case, we have a two method. If you take a look at the target class, we have a two method, say and say to person. So you can see both of these guys are in the signature of public static void and public static void. And also both of them actually start with a say. So both of these guys, both of these methods are qualified as a target method. So whenever this method gets executed, we are going to perform before advice. It's going to display good day, and then it's going to, then it's going to display this, the message, and then after advice will be executed. So it will display thank you. So it's going to be good day and maybe hello world, and then thank you will be executed whenever say method is going to be executed. All right, so let me just repeat one more time. This is the way that how you're going to define aspect. Again, we are not using annotation. Okay, so the same thing can be actually specified using annotation. So here we are defining manners aspect. Aspects define a set of point cards. Here we have only one point card called call say message, and this is the definition of this point card. What it means is that whenever whatever say method or say whatever method gets called, I want to perform this advice and this advice. Okay, all right. So let me actually go to the next example, and we are going to actually execute this application. Then I'm going to address some of the questions you might have. And so this is another example. So here, this is the one definition of the point card we have seen in the previous slide, right? And then we have another point card definition here, point card, and in this case, call say hello to person, and it's receiving a person object. And in this case, it is a star right here. That what that means is, I don't care what kind of return value is. What kind of return value, what kind of the modifier it has, is everything. Okay. And in this case, however, I'm actually specifying say to person methods. So in our example, we have only one method that has this say to person, right? Okay, so the first method say is not gonna be qualified by this this point card. Okay, and it's receiving two string object, and then we're actually taking these guys as actually person object. And so in this case, we also have before advice and after advice, and this is around advice. So around advice will be actually called like this, and here is going to call proceed method. So we are not doing anything. We could actually do something before we are calling the actual target method. Okay, for example, we could actually display something else, and so this is probably not the most feasible example because you're not doing anything before and after, but at least it shows the syntax. It's actually calling the target method. Okay. All right. So this is the wrapper code. So here we have a test application. In this case, we are calling say method and say to person method. Okay. All right. So now you are going to compile both Aspect as well as your Java code. So you're not going to use Java C because Java C is not going to be able to understand the aspect syntax, right? So you're going to use a special compiler called AJC. AJC is, you can think of a superset of Java C. So it understands both the Java code as well as aspect code. Okay, so here it generated class files of my hello world class, which is a target class, and the test Java is our main, the wrapper class, this one. And it also generates a manners aspect class file. Okay. So the AJC understands that the aspect syntax. And then when you run the application, then you are going to see this result. So good day is from the before device, right? Thank you is after device, and the hello world is from the target method. Same thing for this one. Good day and thank you, and then Tom, how are you? That is from your target method. All right, so let me actually see if you have any questions, and then we're going to actually do the exercises together. All right. So can you use AOP if, for example, you want to log not only start and end method events, but something like displaying some field values in different places of the method? Yeah. AspectJ is very flexible. You can do pretty much anything you want. How do you define a point cut in such a case? So, I actually give you an example of very simple point cut definition, but if you actually go to the AspectJ, they have a very comprehensive set of point cut definition syntaxes that you can actually use for the cases that you're just talking about. Okay, so if you use annotations, then use Java-C in this program can be compiled? The answer is yes. That's a good question. Because now we are not going to use aspect syntax. Instead, we are going to use a complete Java syntax. So if you're using annotation, then Java-C should work. And hello world package or class of step 2. Yeah, Bala, I'm not sure. You looks like you are not finishing up your question. So give me the full question. Where to find the AJC compiler is in JDK? No, it's actually from the AspectJ package. So in the hands-on lab that we are going to actually see that. Why we need before and after devices? Because the same can be done with around a device. The answer is yes. Well, the thing is that in many cases you want to just do before. In many cases you want to just after, right? In that case you do not want to use around because around is more expensive than before and after. So around is the most powerful advice, so you can do anything you want, right? However, it is more expensive. So in some cases you want to use just before and after, or and after, if that actually suffices your need. Okay, next question. How aspect is different from a class? Even aspect is also a class with aspect annotation. Yes, I think we actually answered that question, right? Yeah, so if you're using add aspect annotation, then you're basically using add aspect annotation, which is basically, the Java class, So that, yeah, so in that case, it's not that much different from the Java. So you should be able to use Java-C, as we talked about a few minutes ago. Can aspects be compiled within an ID instead of compiling at the command prompt? Yeah, absolutely. So if for example, like Eclipse, you actually see once you actually do the Eclipse, one of the things you specify. Let me actually just see if I can actually run Eclipse, and I'll show you. So most of the IDs let you actually compile the in aspect code, like Eclipse. One of the things you see is whenever you're trying to compile the application, it gives you a bunch of options, including aspect, right? So let me show you in a few minutes. Can you please explain slide 1 again? Slide 1, which slide are you talking about? Slide 1 is just the yeah, Apollo, you have to give me the new number. I mean, I'm not sure what you mean by slide 1. So for example, this is for example, if I want to let's say it looks like it's actually kind of loading it, so let me get back to that later. Why didn't it print out the timestamp for second aspect? Yeah, that's something we're going to actually exercise in the hands-on lab in a few minutes. Where do I get the AJC compiler? Again, it's actually coming from the aspect package. Okay, so yeah, so this is it's actually building it. All right. Okay, now it's let's see. I was actually trying to show you. Let's see. I was actually trying to show you how you can. I mean, you know, whenever you compile it, they actually give you an option of the choosing. All of a sudden, I couldn't find it. All right, so probably this is not that much important. Yeah, so whenever you try to compile the some code, you know, the Eclipse case, it will give you an option of using just regular Java-C or Aspect, and Java-C compiler combination. All right, so let me just move on. Yeah, can you use it with ideas? The answer is yes. I was actually trying to show that. All right, so let me just move on because we don't have that much time. Okay. So this is hands-on lab. So we're going to actually do just a simple exercise, exercise 1. So here, this is the same code. So here we are going to create the, you know, again, this is something you can do with any ID of your choice, okay? Let's see. Yeah, first of all, yeah, let me actually show you, I want to actually show you how to install, okay? You know, basically AspectJ is in the form of the Java file. It's actually provided as part of the hands-on lab. So all you have to do is go to Java SC AOP and then just run this code. Okay, so you know it's already actually included in your hands-on lab zip file. So just do this, then it's going to actually let you install it. So you go to next, and you know it lets you select what Java JDK you want to use, and this is the directory that I'm installing this AspectJ. Okay, so inside of this, you know, directory, you will see AJC compiler. Okay, so everything is done, and then what you want to do is, so I'm going to actually set the class path. I mean, so I need this AspectJ Java file, right? Okay, so I'm going to just set the class path. Okay, and then yeah, I think I have this one already set path. Okay, so I should be able to say AJC. Okay, so it gives you the help screen. Now I am going to you know, I have this code. I create the directory, whatever directory of your choice, and I create the hello world, and then I write the target class. Okay. And I write the aspect. This is something that we have seen. Okay, so whenever say something method gets executed with this kind of signature, I want to have this before and after to be executed. And this is the testing code. And then I'm going to you know, compile this code. So I'm going to actually compile that code in my. I'm going to just go to. Okay, so it's already compiled, so I'm going to just delete class files just to make sure. Okay, and then IJC Java. Okay, so here you can see the class files are created. So if you know, again, AJC is, in my case, is actually in AspectJ 1.6. That's where I installed the AspectJ, right? Okay. All right, now what I'm going to do is I compiled it and I'm going to just run it, Java test. Okay, Java test, and then you're going to see the result. So you see good day, hello world, you know, things like that as we expected. And moving forward, now we're going to actually add another aspect. So here we define another aspect called the Japanese manners aspect, and the point cut definition is here we are, whenever say to person method is getting executed, okay, I want to take it as a person as an argument, and then I'm actually using around. Okay, so basically it's going to proceed. And then the argument I'm actually passing is the name of the person, and then I'm also actually adding the dash san. Okay, so here I already have that code, Japanese manners. Yeah, okay, so I do have it. Oh, looks like I didn't have it, so I have to actually create one. So I'm going to just copy this code. Okay, and then I'm going to compile that. Okay, I have a class, and I compiled it, and then I'm going to run it, Java test. This time you actually see Tom San instead of just Tom. Okay. All right, so I'm going to just stop right there because I like to actually update these hands-on labs and the slide with the annotation-based exercises. So let me just try to address more questions. Okay. So can you use it with IDs? I think I answered yes. Are the prerequisite JUnit extensions based on using aspects? Not necessarily, I would say. Okay. Let's see. What is the result of around advice execution in your test? Yeah, so I think we have seen the example now, right? Okay. How Java AOP is different from Spring AOP? So, the AspectJ is a lot more comprehensive than Spring AOP. Spring AOP is using join point only in the form of method execution. In AspectJ, the join point can be, actually point cut expression can be, in fact, not only in method execution, but a lot of other things. Okay, so, you can think of the AspectJ is more comprehensive superset of Spring AOP. If around can be used anywhere, can we use it in place of start and end also? When you're saying start and end, I'm not sure what he meant. Paula, so send me a question with a bit more explanation of what you mean by start and end. Is aspect same as EJB interceptor? Well, yes or no. So, so interceptor is in a sense, a subset of the aspect. Okay, so that's probably the best way to understand it. AspectJ. Oh, okay, so AspectJ. Paula, you actually, if around can be used anywhere, can we use it in place of start and end also? Yeah, okay, Paula, I still don't understand your question, right? So send me the complete question one more time, please. I think AspectJ plugin needed to be installed in IDE to compile the IDE. Yeah, probably, yes. Yeah, the answer is yes. I mean, most of the cases, if you actually download the Eclipse, AspectJ is, I think, as a default plugin that comes with it. Okay, but if it's not, then you can just install it as a regular plugin. Okay, before and after around functionality can now be implemented using aspect annotation. Does that mean we don't need AJC compiler anymore? Yeah, the answer is yes. Okay. So you should be able to use just the Java C compiler as we talked about. Yeah, so that's the reason I want to actually update the hands-on lab and presentation slide using annotation, because this slide has been made a couple of years ago. Is it possible to build more powerful web applications using Java and AOP without making use of the framework? Yeah, sure. I mean, you should be able to use AOP in pretty much any place. It's like a Java. Okay. But you know, a lot of frameworks are in fact using AOP internally, you know, for implementing the system level functionality. For example, Spring Framework MVC is using AOP internally to provide transaction functionality or security functionality. Okay, so you know, it's the frame. I mean, you know, you do not want to duplicate the code. You know, those kind of functionality of the framework. Framework has done a lot of chores for you to provide those high level semantics using AOP underneath. Okay, is there any other implementation of AOP other than AspectJ? Yeah, I think they have a couple more. Okay, but AspectJ is the most popular. Is annotations are used? Can the JavaC compiler be used to compile the AspectJ files? Yeah, I think the same question has been asked a couple of times already. Yeah, the answer is yes. All right, any other questions? Yeah, I have to actually move on because I have another webinar in 12 minutes on Java EE60 CDI with the JLabel. So where can I get the recording of the session? Yeah, so recording will be